Okay, so hello and welcome back. So in this video we will talk about miscellaneous examples. There is example number 9, 10. There is example number 9, 10, 12, 13. There is not many. There's just a couple of examples here. And then we have some exercises. So let's get started. So miscellaneous examples. Example number 9 is find the value of sine inverse of sine of 3 pi by 4. You want to find the value of sine inverse of sine of 3 pi by 4. Right? So to find the value of sine inverse of sine of 3 pi by 4, basically we know that basically the sine inverse of sine of x is equal to x if x belongs to basically to the limited domain of sine x. Limited domain of sine x is basically when we wanted to define the sine inverse function, we limited the domain of the sine function to negative pi by 2 to pi by 2. So this has to belong to negative pi by 2 to pi by 2. Now 3 pi by 4 is outside of this domain. It's not inside this domain. So you have to somehow bring the angle back to somewhere between negative pi by 2 and pi by 2. So basically, so there are a few things. So we have to bring the angle back to negative pi by 2 to pi by 2, but also the trigonometric ratio has to be sine. Trigonometric ratio has to be sine. Otherwise, for example, I could write this as, for example, the whole expression, I could write it as the sine inverse of, for example, the cos of some angle x, for example, right? But then that doesn't give me x. It has to be the sine inverse of sine of x. So that means that the trigonometric ratio inside has to be sine and not any other trigonometric ratio, because the trigonometric ratio outside is sine inverse, right? So that is something that I need to take into consideration. And so basically, having these two conditions in mind, we can pick one of those basically sets of formulas that we had. So we had basically pi by 2 minus x, we had pi by 2, we had pi by 2 plus x, and that is where the trigonometric ratio changes. So sine becomes cos, so I cannot use this one. Then we have basically pi minus x and pi plus x, in which case the trigonometric ratio does not change. And also I have basically 2 pi minus x, in which case the trigonometric ratio does not change. Now let's start with pi minus x and pi plus x and see what happens if I write this as basically pi minus basically 3 pi by 4. That gives me So pi minus 3 pi by 4 would be some angle over here would be negative 3 pi, negative pi by 4. That would be okay. But also there is one problem here, and sometimes the algebraic sign changes here, and if the algebraic sign changes, there is a problem that basically you will get, for example, something like the sine inverse of, for example, negative sine of some angle here, and this negative sign would have to be taken care of. So you have to preferably do something so that this sign change does not occur. Now let's see if that is possible. So if I go for basically the sign of pi minus x, let's see what that is. The sign of pi minus x is equal to, first of all, the sign doesn't change, meaning that the trigonometric ratio does not change, and you have your x over here. Now basically what we used over here was that we said that let me see if I can find. Basically we had this ASSTCX, right? ASSTCX. So what that means is that in the case, this is basically AS, meaning that the first and the second case, ST is the third and the fourth case, and the CX would be the fifth and the sixth cases. So in the case of the pi minus x, only in the case of sine, only in the case of the sine function, the algebraic sign does not change, because we have ASSTCX. What we agreed upon was that what this means, that basically in the case of this refers to pi by 2 minus x, meaning that in this case there is basically in the case of all of the formulas, all of the 6 formulas, that the algebraic sign does not change. When you have s, that means that only in the case of basically in the case of sine and cosecant, the sign does not change. Again, in the case of sine and cosecant, the sign does not change. In the case of tan and cot, the sign does not change. In the case of cos and basically secant, the sign does not change, and then we have an x over here, which stands for nothing actually. So that means that over here, in the case of sine and cosecant, the sign, the algebraic sign does not change. That means that sine of pi minus x is equal to sine x. Okay. Now, what you need to do is basically, so in order to check my formula, sine of pi minus x, as you can see, is equal to sine x, so my formula is correct. Now I can use it to rewrite this part, right? So I can write this as, and of course there are other ways to do the same thing, but my goal here is to work with these formulas. Otherwise I would simply use the unit circle in this, at least in this particular case. I'll show you what I mean by that. So now I can write, instead of sine of 3 pi by 4, I can simply say that it is equal to the sine of pi minus 3 pi by 4. Pi minus 3 pi by 4 gives me basically is some angle like this. So 3 pi by pi is basically this angle, and negative 3 pi by 4 is starting from here. This is 1 pi by 4, 2 pi by actually pi by 4 is here. So it will give you this angle over here, which is equal to pi by 4. Let me check using the algebra as well. Pi minus 3 pi by 4 is equal to 4 pi minus 3 pi, which is equal to 4 pi minus 3 pi is equal to pi divided by 4. That's sine of pi by 4. So that means that sine of 3 pi by 4 is actually equal to sine of pi by 4. And I really didn't have to go through all of these steps in order to understand this, because you can see that if you have this, suppose that you have the angle 3 pi by 4, which is this angle over here. This is 3 pi by 4. Now the sine of this angle is basically this distance on the vertical axis. Of course, I know that if I draw this angle, the sine of the two angles are going to be the same, and this angle is just simply 45 degrees. That means that I can say that 120, 135, so that means that I can say that the sine of 3 pi by 4 is just simply equal to the sine of pi by 4. And that's the end of the story. I could have told you this in just 5 seconds, 10 seconds. But the goal here is to some kind of work with these formulas to get the hang of them, because you're going to need them. So then I can write the sine of 3 pi by 4 as sine of pi by 4. And now the question that we wanted to answer was the sine inverse of sine of 3 pi by 4, and that is equal to basically the sine inverse of sine of pi by 4, and that is actually equal to pi by 4 because pi by 4 belongs to this interval here, which is negative pi by 2 comma pi by 2, right? So that is the first question. Now there is a problem here. Actually, the actual question that was in the text, example number 9, it wasn't 3 pi by 4, it was actually 3 pi by 5. So I made a mistake there. So we will have to now go back and again do example. This was actually not example number 9. This was something that I made up. So now we will go back and do example number 9, which is basically instead of 3 pi by 4, we have to find the answer for 3 pi by 5. Okay. Okay, so still I would say the same example that we were doing before, and I made a mistake. It was basically the sine inverse of, sine of 3 pi by 5. I thought it was 3 pi by 4, so 3 pi by 5, And now 3 pi by 5 is the same thing as I don't really know what sort of angle that is, meaning that you have 3 times pi divided by 5. So basically I know that basically if I have the sine, basically the sine inverse of sine of x is equal to x if x belongs to basically negative pi by 2 to pi by 2, right? So now let's see what this angle is. 3 pi by 5 is basically some angle like, so if you want to convert this angle into degrees, you know that basically pi radians is equal to 180 degrees, which means that basically 1 degree is the same thing as pi divided by 180 radians, right? Which means that I'm sorry, I should have actually converted the other way around. So that means that basically 1 radian is the same thing as 180 divided by pi degrees, which means that basically 3 pi by 5 radians is the same thing as 3 pi by 5 times 180 divided by pi in degrees. So that is the same, so I can write this as 3 pi times 180 divided by 5 divided by pi, and that's the same thing as in degrees, and that's the same thing as 3 pi times 180 divided by 5 times 1 by pi, and then pi and pi you can cancel out. You have 3 times 180 divided by 5. Now I think you can simplify this over here, right? That 180 divided by 5, you'll get 3 times 5 is equal to 15 and 36 degrees. So 180 divided by 5 is equal to 36. So 36 and 1. 3 times 36 is something about that's 90 and 18, 108 degrees. That is all in degrees. That's 108 degrees. So that is basically, and therefore I can say that basically 3 pi by 5 radians is equal to 108 degrees. Now 108 degrees is of course outside of this domain, meaning that I have to somehow bring this angle back to this domain. Now in order to do that, what I need to do is that I need to now there are different possibilities for me. I can use pi by 2 minus x. I can use pi by 2 plus x. I can use pi minus x. I can use pi plus x. I can use 2 pi minus x. And there is no possibility here. And we said that basically the mnemonic that we had to memorize for this was AS, ST, and CX, right? So now if I use pi by 2, anything like pi by 2 minus x or pi by 2 plus x, then sine becomes cos, and then of course I could not take the sine inverse of cos. That would be a problem for me. I could either use pi minus x or pi plus x, and I could use 2 pi minus x. I'm going to start with pi minus x. Now, and in the end, I'm going to show you a very simple way to figure this out without going through all of this trouble. But all of this trouble is necessary if you want to work with the algebraic side of trigonometry. There is no other way. Meaning that basically, if I have the sine of 3 pi by 5, sine of 3 pi by 5, or let's say that basically I have the sine. What is the sine of pi minus x? What is the sine of pi minus x? So since basically I have a pi over here, of course there is no trigonometric ratio change. So I'm going to get the sine of x, and about the angle, only in the case of sine there is no algebraic sign change. So that means that sine of pi minus x is actually equal to sine x. I think I have too many windows open here. So now if I go back to my formulas, I can see that sine of pi minus x is equal to sine x, exactly as we had it over here, right? So that must be something that I could work with, right? So now if I write the sine of 3 pi by 5, the sine of 3 pi by 5, that based on this formula, it's equal to the sine of pi minus 3 pi by 5. Now what is pi minus 3 pi by 5? Pi minus 3 pi by 5 is equal to 5. That is 5 pi minus 3 pi. That's 2 pi by 5. I don't even know what sort of angle that is, but we can find out that is basically 360 divided by 5 is something like 360 divided by 5 is something like 72 degrees. So 72 degrees is of course less than 90 degrees, so we can accept that. So then I can say that the sine of basically 2 pi by 5 is equal to the sine of 3 pi by 5, and therefore I can use it in my formula. So the sine of 3 pi by 5 is actually equal to the sine of 2 pi by 5, and then I can use it in my formula, right? Now, so then I can write the sine inverse of sine of 3 pi by 5. I can write the sine inverse of sine of 3 pi by 5. I can write it as the sine inverse of sine of 2 pi by 5, which is equal to 2 pi by 5, because 2 pi by 5 belongs to negative pi by 2, negative pi by 2, 2 pi by 2. And that is hopefully the right answer here. That is actually the right answer here, right? Okay. Now the next question that we have. Okay, so the next question that we have is basically question number 10. But for whatever reason, I could not actually solve this problem. There is something that needs to be done here, and I do not really know how they have decided that. let me explain to you what the problem is. You see over here, basically the problem is that you want to show that basically the sine inverse of 3/5 minus the sine inverse of 8/17 is equal to cos inverse of 84 by 85, right? The cos inverse of 84 by 85. Now, there is no good way to solve this problem, meaning that you could probably, I'm not really sure if it's possible, or if it might be too much trouble, but you could write the sine inverse of some ratio as basically 2 times tan inverse of some other ratio using this formula. And then again you can do the same thing with this one, and then you have 2 times tan inverse of some ratio minus 2 times tan inverse of some ratio, and then you can take the 2's out, and then you would have 2 times, for example, tan inverse of something, which, well, it's too much trouble. Let's not do that. Now, the way that has been basically used in this exercise is that they have written the sine inverse of 3/5 as, for example, some value like x, and the sine inverse of, for example, 8/17 as some value like y, for example. Now, what you can do is that basically you know that basically the sine inverse of x plus the cos inverse of x, the sine squared x plus, not sine inverse, but you know that the sine squared x plus cos squared x is equal to 1, which means that cos squared x is equal to 1 minus sine squared x. Or you can say that basically cos x is equal to plus or minus the square root of 1 minus sine squared x. So that you already know. So since you have the sine of basically this now over here, what you can do is that you can rewrite this expression as, for example, 3/5, or the sine of x. The sine of x is equal to 3/5. And also you can, here what you can do is that you can say that the sine of y is equal to 8/17. The sine of y is equal to 8/17. Now I have the value of the sine of x, so I can put it in this formula and calculate the cos of x. I have again the value of sine of y, I can put it in this formula and calculate the cos of y. But the problem is that in order for you to know, basically here what we have is basically the cos of x is equal to plus or minus square root of 1 minus sine squared x. And usually you need, of course, usually you have some way to decide basically which one to take, meaning that you can write this as the cos of x is equal to positive square root of 1 minus sine squared x, or you can write this as cos of x is equal to negative square root of 1 minus sine squared x. And depending on whether cos of x is positive or negative, you have to take either this one or this one. But here the problem is that there is no way to know whether cos of x is going to be a positive value or a negative value, because based on the information that we have, basically I know that the sine of x is 3/5. 3/5 is some ratio, which means that basically x is some angle whose sine trigonometric ratio is positive. That means that x is some angle either in the first quadrant or in the second quadrant, right? And whether you had an angle over here or over here, the sine would be positive, and so any of those two angles would satisfy this this equation. But of course there is one thing that you can take into consideration now that I think about it. So we took we restricted the domain of the sine function to negative pi by 2 to pi by 2, right? So we took the domain of basically we said that the sine inverse function is a function that goes from negative 1 comma 1 to the range which is negative pi by 2 to pi by 2, and that is a closed interval. Now since that is the case, then that means that basically this would be the restricted domain of sine function, not sine inverse function but sine function, which means that basically if I had, for example, if I had this piece of information here, which is sine x here, when you tell me that the sine of x is 3/5, then 3/5 is some ratio. For example, 3/5 would be this basically this distance on the vertical axis. Then of course, then you could normally argue that, okay, so I have some angle here, this angle, the sine of this angle would be this value, or the sine of this angle is again this value, so this angle would be, so I have two angles that satisfy this equation. But since we have restricted the domain of the sine function to negative pi by 2 to pi by 2, meaning that from here negative pi by 2 would be here and pi by 2 would be here, then of course I can automatically or basically rule out all of the angles that I would get in the second quadrant, and I know that basically now that the angle is in the first quadrant. Now if the angle is in the first quadrant, then of course the cos of the angle is positive, meaning that then I can write my equation as the cos of x is equal to positive square root of 1 minus sine squared x, and the problem is solved. Now I couldn't actually figure this out on my own when I was thinking, so now that I was talking about it, all of a sudden I got the solution. So then what you can do is that you can basically write cos of x is equal to positive square root of 1 minus sine squared x, 1 minus sine squared x, and basically then basically cos of x is equal to the square root of 1 minus sine squared x would be 9 by 25, and then I can write this as the square root of 25 by 25 minus 9 by 25, which is equal to the square root of 16 by 25, which is equal to 4/5. That means that basically cos of x is equal to 4/5. So problem actually solved. And then I can use the same logic. Basically sine of y is equal to 8/17. I know that sine of y is equal to 8/17, which means that I can write basically cos of y is equal to the square root of 1 minus sine squared y 1 minus sine squared y. So cos of y is equal to the square root of 1 minus 64 by, I don't know, 17 squared is equal to some large number. I don't really know what that is. I used to know that. 289. So that is 289. And then basically I can write this as the square root of 289 by 289 minus 64 over 289, and that gives me basically what is 289 minus 64. That's a 5, and that's a 225, and I think this is 15 squared. 15 squared is equal to 225. That is 15 squared. 15 squared. So this is equal to basically the square root of 225 by 289, which is equal to basically 15 by 17. So what that means is that then the cos of y is equal to 15/17. Cos of y is equal to 15/17, and so now cos of x is equal to basically is equal to 4/5, and cos of y is equal to 15/17. Sin y is equal to sin x is equal to 3/5. Sin x is equal to 3/5, and sin y is equal to 8/17. Sin y is equal to 8/17. So that is basically that. Right? So that is basically the information that I have now. Now, what I can do now is that I can use the formula cos of x minus y is equal to cos x cos y, cos x cos y, cos x cos y plus sin x sin y. So so then cos of x minus y would be equal to basically cos x is 4/5, cos y is equal to 15/17, plus sin x is equal to 3/5, and sin y is equal to 8/17. 8/17. So that is the same thing as now. You can simplify this. 3 times 4 is equal to 12/17 plus 24 by basically 5 times 17, right? So I can write this as 5 times 17, and that's 5 times 60 plus 24, which is equal to 84 by 5 times 17. 84 by 5 times 17 is equal to, that is a 50 and 35, that's 105. So 84 by 105, and I think I might have made a mistake here. 5/17 plus 3/5 times 8/17. There is a 17 here and a 12. And there is 5 times 17, and 3 times 4 is equal to 3 times 8 is equal to 24. Then you have 5 times 4 is equal to 60, and 5 times 17 is equal to 50 and 35. Oh, that's 85, I'm sorry. That is 85. Okay, so that is 84 by 85, right? That is 84 by 85. Now 84 by 85, basically, so that basically means that the cos of x minus y is equal to 84 by 85. That means that basically, cos inverse of basically cos inverse of 84 by 85 is equal to x minus y. And now what is x, what is y? We said that x is equal to sine inverse 3/5 over here. We said that x, this is x and y. So sine inverse 3/5, sine inverse 8/17. Sine inverse 3/5 minus sine inverse basically 8/17, right? And that is the cos inverse of 84 by 85. And therefore, and hence the, let's call it the identity. I'm not really sure if that's the good name, but identity is proved. Okay. Now, the next question that we have is question number 11. Question number 11, and that is basically, you want to show that, for example, the sine inverse of 12/13. You want to show that the sine inverse of the sine inverse of 12/13 plus the cos inverse of 4/5 is equal to, as actually there is more to come, plus the tan inverse of 63/16 is equal to pi. Okay, so I think we could actually use the same method that we used before in order to tan inverse of we could use some similar method in order to do this one as well. So, but I suppose we need some more space here. That the space is most probably not basically 263. Okay, so the question is the sine inverse of, again the question is the sine inverse of 12/13 plus the cos inverse of 4/5 plus the tan inverse of 63/16 is equal to pi. You want to prove this. Now if I take basically you can say, let, for example, the sine inverse of 12/13 be equal to x, for example, and basically the cos inverse of 4/5 be equal to y, and the tan inverse of 63/16 is equal to, for example, z. So that implies that basically sine of x is equal to 12/13 and cos of y is equal to 4/5 and tan of z is equal to 63/16. And now what we can do basically now if we use the relationship for tan of x plus y, we know that tan of x plus y is equal to basically tan x plus tan y 1 minus tan x tan y, right? So if I use this, then I can write x plus y, as the tan inverse of basically this whole thing over here, right? I can write the whole thing over here, and that seems to prove the same thing, right? So let's do the same. So meaning that I need basically tan of x, tan of y, and so I need to calculate tan of x and tan of y, and to calculate tan of x and tan of y, I need to calculate cos of x and sine of y, and then divide and then get the tan of x and y. So let's do that. Okay, so now in order to calculate basically the cos of sine x, so I know that basically sine squared x plus cos squared x is equal to 1, which means that sine squared x is equal to 1 minus cos squared x, which means that sine x is equal to plus or minus square root of 1 minus cos squared x, and also cos squared x is equal to, so that is one thing that we can use here, and also cos squared x is equal to 1 minus sine squared x. So cos x is equal to basically this plus or minus square root of 1 minus sine squared x, right? So cos x is equal to plus or minus square root of 1 minus sine squared x, and sine x is equal to plus or minus square root of 1 minus cos squared x. Now, basically, again, we need to decide whether we need to take the positive or negative side of this for this case, basically. And I know that basically sine x is some positive value, which means that again, we restricted the domain of the sine function to negative pi by 2 to pi by 2, and that basically means that since sine of x is equal to a positive angle, that has to be in the first quadrant, like what we discussed in the previous example. So if that angle is in the first quadrant, then that means that the cos of that angle is also positive, which means that I can write the cos of x is equal to the square root of 1 minus sine squared x, and basically and so cos x is equal to basically the square root of 1 minus sine squared x would be 144 to 169, 144 to 169, and that's the same thing as let's just calculate this here. So the square root of 1 minus 144 to 169 is equal to the square root of 169 by 169 minus 144 by 169. And what is 169 minus 144? I think it's 25. So it's the square root of 25 by 169, which is equal to 5 over 13. 5 over 13. So that is basically 5/13. That is 5/13. Moreover, to calculate cos of y, to calculate sine of y, basically we know that sine y is equal to the square root of 1 minus sine, basically 1 minus cos squared y. 1 minus cos squared y. Which means that basically sine y is equal to the square root of 1 minus 16 over 25. Now what is this thing? Let's calculate it here. The square root of 1 minus 16 by 25 is equal to basically the square root of 25 25ths minus 16 by 25, which is equal to the square root of 9 by 25, which is equal to 3/5. So this is equal to 3/5. Now, what I can do, now I know basically, I know sine y, I know cos, I know sine y, I know cos y, I know sine x, I know tan. So basically I can calculate now what is tan x. So tan x is the same thing as sine x by cos x, which is equal to basically sine x is equal to 12/13, and cos x is equal to 5/13, which is equal to 12/5. That is tan x. And tan y is equal to sine x by cos, tan y is equal to sine y over cos y. Now sine y is equal to 3/5, and cos y is equal to 4/5. 4/5, that's the same thing as 3/4. Now I can use the formula that we discussed before, meaning that we said that tan of x plus y is equal to basically tan x plus tan y, 1 minus tan x tan y, 1 minus tan x tan y. So which means that basically, tan of x plus y is equal to basically 12/5 plus tan y is equal to 3/4, and 1 minus 3/5 times 3/4. 12/5 times 3/4. Now you can calculate this here as basically I calculate this over here, so I write this as basically LCM. For example, 20 divided by 5 is equal to 4. 4 times 12 is equal to 48. 4 times to 48, and 5 times 15. And this is the same thing as I can simplify this as basically 1 minus 36 by 20, and then I can write this as 48 plus 15 is equal to 50, and 13 50, so 48 plus 15 is equal to 13/1 and 63/20ths. And 1 minus 36 by 20 is the same thing as 20 by 20 minus 36 by 20, which is equal to negative 16/20ths. So that's negative 16/20ths. These two will be cancelled out, and so you would have And so you would have basically negative 63/16. 63/16. 9, so you cannot simplify this. That is the same thing as negative 63/16. Now what happens here is that as you can see, tan of z is equal to basically tan of z, we said it's 63/16. So that is equal to negative tan of z, right? Negative tan of z. Okay, so now here we need to do a couple of things, meaning that basically these are all important problems that you need to understand how to solve these problems. So basically you can say that based on what we saw, you can say that tan of x plus y is equal to negative tan of z, right? Negative tan of z. Now this can have two different types of meanings. So you know that basically tan of negative z, of course, is equal to negative tan z, of course, right? That is of course always true. Tan of negative z is equal to negative tan z. But that can have another meaning as well, meaning that I can write this as basically I can write this as basically tan of x plus y is equal to tan of basically negative z, right? Or another way that I can write this is that I can write basically tan of x plus y is equal to tan of basically pi minus z. And the reason why that happens is that basically over here we said that basically tan of pi minus x is equal to negative tan x, right? So tan of pi minus x is equal to negative tan x. Tan of pi minus x is equal to negative tan x. So which means that I can write, so based on this, let me rewrite this expression here. So I know that basically tan of x plus y is equal to negative tan of z, right? Now, in the formulas that we had, we said that tan of pi minus x is equal to negative tan of x. Negative tan of x. Which means that instead of writing negative tan of z, I can write tan of pi minus z. Tan of pi minus z, right? So tan of x plus y is equal to tan of pi minus z, right? So what that means is that now I know that basically tan of x plus y is equal to tan of negative z, or tan of x plus y. I can write the or over here, and I can basically clear this out. So, and I know that tan of x plus y is equal to tan of pi minus z, which means that either basically either x plus y is equal to negative z, or basically x plus y is equal to pi minus z, right? Is equal to pi minus z. Now it seems that this case is impossible because as I can see here, x, y, and z, x, y, and z are seem to be basically, this is the sine inverse of some positive ratio of a ratio, and so how can you figure out if this is a positive value or a negative value? The only way that you can do it is basically calculate it. So let's see if we can figure that out. So we have, let me make a screenshot here. Okay, so now basically to understand this part, what you need to do is that basically what we need to know, we want to check whether basically this is at all possible that x plus y is equal to negative z, and we know that basically x is equal to sine inverse of 12/13, y is equal to cos inverse of 4/5, and z is equal to tan inverse of 63/16, right? Now, in order to figure that out, so first of all, we said that x is equal to or sine of x, actually we said that sine of x is equal to 12/13, right? Now we restricted the domain of the sine function to negative pi by 2 to pi by 2, right? So that means that the domain of the sine function goes from negative pi by 2 to pi by 2, meaning that it goes from here all the way up to here, right? So now if sine of x is 12/13, which is a positive value, that means that x has to be somewhere in the first quadrant, because if it was in the fourth quadrant, then the sine of x would be a negative value. So that basically means that basically x is an angle in the first quadrant. Now, since x is an angle in the first quadrant, now we know that x over here is equal to sine inverse of 12/13, right? X is equal to sine inverse of 12/13, and so it's just that angle, right? That angle happens to be in the first quadrant, which is greater than 0. So basically x, which is sine inverse of 12/13, is a positive value. Now, y, basically we said that y is equal to the cos inverse of 4/5. So the cos inverse of 4/5. Now, basically the range of the cos inverse function is always a positive value. It's between it's always between 0 and pi. So you have 0 over here and pi over here, and basically this is the range of the cos inverse function, So that means that all the values that you're allowed to enter into cos inverse function, you're going to get some angle in the you're going to get some angle between 0 and pi. This is 0 and this is pi, which is going to be a positive value anyway, right? So you have no problem there. And z basically is the same thing as tan inverse of 63/16. Tan inverse of 63/16. Now the tan function, basically the tan function, about the tan function, or basically so what this means is that basically tan of z is equal to 63/16, which is a positive value. Now we restricted the domain of the tan function to negative pi by 2 to pi by 2. So this is the domain of the tan function. So if my angle is somewhere down here in the fourth quadrant, here basically sine is negative, and here basically sine is negative, and cos is positive, so here tan is negative. In the first quadrant, basically, in the first quadrant, your sine is positive, your cos is positive, so that means that tan here is positive. And basically, since basically z is the tan of z is basically a positive value, that implies that z is an angle in the first quadrant. Now, if z is an angle in the first quadrant, then this means that that means that in the first quadrant, of course, so of course then the value of z is positive. So that implies that z is greater than 0. So so now here what we are saying is that x plus y is equal to negative z, and x is a positive value, y is a positive value, so it has to result in a positive value, and z is a positive value as well. So what if you take a look at this, a positive value plus a positive value is equal to a negative value, because z is positive and negative times positive is negative, so this side becomes positive, this side becomes negative, so which is impossible. So that way you can show that this is not possible. And so x plus y is equal to pi minus z. And therefore you can basically conclude that x plus y is equal to pi minus z, which means that x plus y plus z is equal to pi. And now what is x plus y? X, y, and z. So x is equal to the sine inverse of 12/13. Y is equal to cos inverse of 4/5, and z is equal to basically tan inverse of 63/16, and that is equal to pi, and that is what we wanted to show here, that basically all of this whole thing that we have here is equal to pi. Therefore the identity is proved. Now this of course takes a little bit of reasoning and thinking and so on and so forth, but of course anybody that wants to work with mathematics needs to know all of these things. There is no other way, otherwise you will get stuck somewhere. There is no way to get around these things. This is trigonometry, one of the most important things in mathematics, of course. So in the next video we will talk a little bit about number 12 and 13. So I'll see you in the next video, and thank you.